This video is brought to you by Sporlan. Quality, integrity, and tradition. Today we have a call on a kitchen AC. At least that was the way it was told to me, was the kitchen AC wasn't working properly. But when I got here, my conversation with the manager, whenever I get to a service call, I always start with a conversation, okay? Walking up to the manager, shaking his hand, asking him how things are going. So my conversation with him led to several ACs not working. All right, he said, like, basically out of all the ACs, maybe one or two he thinks might be working. So again, big picture diagnosis, you know, walking in the door, that conversation with the manager, I could have just walked up and said, kitchen AC down, okay, went on the roof, fixed kitchen AC, moved on. But just a general conversation led to a lot more stuff going on, led to, hey, do you mind, I'll go ahead and check out all the other ACs? Yeah, please do, I'd appreciate that. I am looking for service technicians in the Southern California area, specifically the Greater Inland Empire and South Orange County. I have a small service company, nothing big, okay? Very small. We service mainly restaurants. The kind of technician that I'm looking for is the technician that picks up after himself. When I go up onto the roof, I don't want to see all this trash. It does not take very much time to pick up after yourself. I understand sometimes you may forget a part, but look at all these belts. Look at all the metal mesh filters. Simple things like, hey, I'm not blaming someone for that because maybe the customer didn't want to fix it. Look at how that drain is propped up with a cinder block, but at least let's make sure we note it down on some paperwork. I want someone that is willing to look at the big picture and look past the fact that this unit needs to be replaced and that it's a piece of junk, okay? Even if it is, once I have the customer's permission, I'm gonna straighten out the fins on that condenser. I'm gonna treat it like it's a brand new unit. When I'm all finished, I'm not gonna leave the panels on the ground, okay? I understand accidents happen. If you're an experienced tech, I'm really looking for you. If you're a tech that doesn't have so much experience, I'm even willing to train. I'm looking for techs that are willing to look at the big picture, spend some time, and fix things right. If you're that tech, send me an email. All right, so the complaint is the kitchen AC is not working. When I went downstairs, they had a blank thermostat. Whether or not the thermostat is for this AC, I don't know. I did not troubleshoot past that point yet. Where I'm gonna start is I'm not gonna disturb anything. I'm just gonna do a visual inspection on the unit. Condenser looks like junk, disconnect switch is on. Drain looks a little funky, but hey, look at, the gas valve is off, okay? Things like that. We're propping a drain line with a cinder block and a piece of 2x4. Metal mesh filters missing out of the outdoor air hood, okay? Once we just do a visual inspection, we're gonna go ahead and open up the electrical panel. Now, keep in mind that we as service technicians can't necessarily turn everything off when we're working on it, but we got to use common sense. We got to be vigilant and be careful, okay? Another thing that I'm noticing as I'm looking around is there's only 2 screws in this panel. Nothing on this side. Oh, there's one over here, okay? So I'm just visually looking at how many screws there are. Here in Southern California, screws in a panel are really big because we get crazy wind events down in Southern California called the Santa Ana winds. Up in Northern California, we get the Diablo winds. But essentially, they're just crazy up to 70-mile-an-hour gusts that come, and all panels have to have multiple screws in them, okay? So we're gonna open up that electrical panel and see what we can figure out. All right, understanding the sequence of operation on our units is very important. If you don't understand the sequence of operation, and say you're an apprentice or a novice tech, call and ask for some help. You know, I'd appreciate if my guys just call me and say, hey dude, what's the sequence of operation on this unit? What do I have to look for? Because if you know anything about the carrier units, this unit has got a compressor lockout board. It actually has 2 of them. And if we power cycle the unit, the compressor lockout board will reset. So we have to know how to diagnose and check to see if the compressor lockout board is locking the unit out before you power cycle the unit. Our compressor lockout boards are right here. These 2 guys right here. And if you look on the back of the panel, I bet you the schematic's missing, but there's usually a legend and it tells you which board goes to which unit. But you can actually test the compressor lockout board on these carrier units by checking power at the X terminal. So we're gonna do that and see what happens, and it'll tell us if we've got an issue. So first thing I'm gonna do real quick is just make sure that I have 24-volt power going to my thermostat, checking on the C terminal, the common, and the R terminal. So we are sending 24 volts down to the thermostat currently. All right, now if our compressor lockout board was off on lockout, first off, we already checked R to common, we get 24 volts. Now, if we go from common or the C terminal to the X terminal, if we had voltage, that would indicate that we were off on a compressor lockout, so we're not. So our next step, we know that we have R to C, 24 volts, so we know our transformer's good. This is sending the power down to the thermostat. We're not getting power coming back up, because when I go from C or common to Y1, I get some weird low voltage. I don't get enough, I get like 8 volts, which is weird. Nothing to Y2, nothing to W1, nothing to W2, nothing to G. So at this point, we could go downstairs to the thermostat, but since I'm already up here, I'm gonna go ahead and diagnose the unit with some jumper wires. So we're gonna go ahead and simulate cooling and see what happens. So first and foremost, we're gonna take a jumper wire from R to G. The indoor blower should turn on, and it did. So now we have a heat load going across the evaporator coil. Without that heat load, it could be problematic. The next thing I'm gonna do is jump from R to Y1, simulating a thermostat call, and nothing is happening. That's a problem. So, because I understand the sequence of operation, I'm gonna go ahead and check to see if I have a call for cooling coming back to the compressor lockout board. I do not have a call for cooling coming to the compressor lockout board. Again, understanding the sequence of operation, what that means is I'm sending power to the economizer area and it's not coming back. So we need to look into that. Maybe we were calling for free cooling right now. Maybe there's a problem. There's a lot of typical carrier problems here, and I already have a hunch as to what's going on, but we'll jump over to the economizer section and see what we can figure out over there. All right, I've still got a call for cooling. I left that there. This is what happens when people put these units on these giant curb adapters too. I'm standing on a cinder block. All right, so we're gonna open up the filter area, and they've got these weird, they got a filter changing company that comes over here and puts these weird media things in. It's like the solid junky filter crap, and it's plugged solid. Filter is plugged completely. So here's my economizer module. We need to figure out our problem. Understanding the sequence of operation on this unit, power comes into that economizer module, and if the economizer is not calling for free cooling, then it goes to the compressor contactor. The economizer is not open. This module is bad. We've got corroded components. This is low voltage. It's okay to touch. I'm not gonna get hurt, but I'm still being careful. We've got wires just laying in here that are broken off their terminals. So this economizer is not running right now. This module is not working. So we're gonna look to see what we gotta do to bypass this for now, because just because of all the broken wires and the corrosion on the terminal, maybe you guys can't see it, but it's trash. Okay, just for giggles, I know the economizer module is all corroded, so there's no point in doing much with that. But what I'm gonna do just to be safe is I'm gonna jump out Y2 also, because sometimes people, I know people are gonna ask me. Okay, so now Y2 is jumped out also. And so we've got 24 volts going to Y1, Y2, and we have absolutely no cooling. And that's because it's getting lost in the economizer module. So what we're gonna do is we're gonna go ahead and power this unit down now. We're gonna go ahead and disconnect all of our jumpers, and temporarily I'm gonna bypass this economizer module until we can talk the customer into replacing it. We gotta get cooling going so I can further troubleshoot at a minimum, okay? So, again, I understand the sequence of operation on this unit, so I'm gonna do some stuff. You guys gotta stare at a schematic to figure it out yourselves. All right, if I did my job correctly, which I think I did, I pulled off the wires coming from and coming back. Just taped them off temporarily because we're not destroying anything, just in case the customer wants to fix it. I went ahead and permanently disconnected the heat because the gas valve's turned off, so I'm sure it's got a cracked heat exchanger or something. But I'm just focused on the cooling right now. So now I'm still going through my compressor lockout boards. So we still got safety protection in the unit, and we're gonna fire it up and hope nothing blows up in my face. So if I did my job right, if B stops trying to attack me, then you like this too. Look at ground wire's not hooked up. But if I did my job right, this won't blow up in my face. So I'm gonna stand to the side, turn it on. No big boom yet. And we're gonna go ahead and test the thermostat. So what we're gonna do is go from R to G. Fan runs R to Y1. Contactor chattered, but compressor turned on, but condenser fan motor's not running. That's interesting. Let's go from R to Y2. Yeah, condenser fan motor should be running right now, and it's not. So that's a problem. We'll have to dive into that. And the second stage should have come on by now too. It's interesting. I'm gonna kill power. My condenser fan motor relay is right here. We should be energizing that. Interesting. Oh, I see where the problem is. Okay, cool. So I forgot to put a wire on when I bypassed it. There's a blue wire right here, and this blue wire is power for the condenser fan motor. So I gotta put that back on the terminal. So we'll get it. So the condenser fan motor should have came on right with the first stage compressor, and it didn't. Okay. We're gonna go ahead and try this again. So R to G. Screw this up. There we go. R to G, indoor fan. There we go. R to Y1, condenser fan and compressor contactor. Still nothing. What is going on? I'm screwing something up for sure. Let's test voltage at the compressor condenser fan motor. Nothing, no voltage. Something got screwed up. Hey, it happens. We mess stuff up. Especially when I just kind of try to rewire things using my brain. I figured it out. I just grabbed the wrong wire. That's all. No big deal. Nobody's perfect, guys. I make mistakes just like everybody. So I figured out what I did. I made an assumption because the wire was blue that it was the blue wire going to the fan contactor, and it wasn't. Grabbed the wrong wire. Essentially, I was sending power back to the Economizer module. So, got that out of there. I'll confirm right now. Yep, got the right wire now. So, this time, if it doesn't turn on, then I'm an idiot. And I'm going to show you guys on camera how much of an idiot I am. Power on. Okay. Indoor blower motor. Okay. Now I know there's still a problem with Y2, but I want to troubleshoot Y1 first. So Y1. There we go. Condenser fan motor's running. Compressor 1 running. Compressor 2 is not running. Go ahead and jump out compressor 2 now. Not good to run the unit with the outdoor fan open either, the panel, but I'm doing some testing right now. So if I was doing refrigerant testing, we couldn't have this panel open. Second compressor turned on. We're good now. So we've got a call for cooling. We need to put the panel on, secure it so we can test all the cooling stages to make sure it's working properly now. Before I test cooling, what I did was I pulled the belt off. The belt itself is pretty worn out. it's got some weird wear pattern on the side where the belt's worn down. It's kind of probably hard to visualize with the camera. There's like a nick in the sidewall right here where it's like coming apart. But I really want to point out is the motor pulley and the motor pulley and the blower pulley, basically, or sheave, whatever you want to call them. I can physically feel with my fingers. It's kind of hard to show you on a camera that they're bad. But I have a bad pulley over here, and I'm going to show you guys. If you guys don't know how to feel for a bad pulley, you can use a pulley gauge. Okay, so this is a pulley gauge. It's made by Browning. I'll put a link in the show notes, but you can get these all over the place. You find what size belt you have, and I have an A belt on there, okay? We've got two pulleys here. One of them is good and one of them is bad. This is a good one. What you do is you take the gauge and you line up this corner with the edge of the pulley or the sheave, and it should rest flat on the surface of the pulley right on the bottom right here. This one rests flat. Okay, there's no grooves built into it. Essentially, if you look at a pulley, it needs to be a perfect V shape without any notches in there. Now, here I have a bad pulley. This one's visually bad, but if we take the pulley gauge and we notice on that far corner, it's not that it doesn't touch here, but if you push it on the bottom, it does not rest flush. Either side that I use, it does not rest flush. It is a bad pulley. All right, I'm gonna go ahead and throw the belt back on here. I believe there's a new belt in here, yeah. You know, I'm probably gonna get hecked for this, but I'm gonna go ahead and slap the belt on. You're not supposed to put them on this way, it stretches them out. This one's still kind of loose. But we know that if we tighten this up too much, the belt's gonna get stuck in the pulley and it's gonna break the belt and cause problems. So I know we're gonna be running low airflow on this unit because of the pulley that's worn out and also because of the blower wheel that's dirty. But at least we know it works. We're gonna put this guy back together and finish our cooling test. All right, we are probed up on the first stage compressor. If you wanna know how to tell which one's the first stage compressor, on the carrier units, you can look at the evaporator. On these carrier units that have a straight evaporator and even the slanted evaporator, the bottom of the evaporator is gonna be the first stage, the top's gonna be the second stage. So just follow the liquid line and the suction line, and you'll know that this is all the first stage. So suction temperature, suction pressure, discharge temperature, liquid temperature. We're gonna go ahead and start it up, let it stabilize, and then evaluate what it's doing. All right, using Measure Quick. Again, I usually don't use the diagnostics personally. I just like all the information at my fingertips, but the diagnostics I'll show you are usually pretty on point too. So first off, we're running a low load on this evaporator. Let's go look at my my outdoor air temperature right now is 64 degrees. My return air temperature is 62 degrees, okay? We've got a low load for sure. All right, let's go look at our numbers though. Superheat's high, subcooling's on the hair side of being low, but not horrendous. Refrigerant pressures are on the hair side of being low. I am kind of leaning towards low airflow, possibly low charge, based on those superheat numbers. Let's see what Measure Quick has to say. Measure Quick says low load on the evaporator for sure. Potential return air duct leakage, I agree with that. They probably do have it. System may be undercharged, there may be a restriction. There's all kinds of problems. Now we also know that we're probably running an abnormally higher than normal head pressure because of the messed up condenser, so we have to take that into account too. The condenser's like almost flat in a bunch of spots, so we've got poor heat transfer on the condenser too, which is probably adding to an elevated head pressure higher than what it actually is. But we're gonna go ahead and jump on the second stage and see what that has to say. Again, we're just getting them a list of problems. I mean, in all honesty, of course, just like everybody else, I'm gonna tell them to change this unit, but I'm gonna go to them with a big picture diagnosis and say, I need to spend this much money straightening out the fins on the condenser. We need to, before I do anything with this, I'd probably go ahead and pull the blower assembly, clean it, recover the charge, weigh it back in, check the heat exchanger, you know, that kind of stuff. So we'll get them a whole list of things, and then we'll go from there. So next we're gonna check the second stage. All right, so the second stage is actually doing pretty darn good. It's actually probably doing a majority of the work. According to Measure Quick, we're kind of on point with our pressures. Let's see, our superheat's definitely lower. Still a little bit on the high side, subcooling, you know, right in range. Let's see what Measure Quick has to say. Low load for sure. I mean, I agree with the low load and possible return air duct leakage. Again, very good possibility. Let's look at discharge line temps right on point. Our split's still going to be the same, about 18 degrees. We're on the low side of the split. Yeah, airflow is a little bit higher. Okay, so refrigeration wise, our system is working. We have a potential leak and or it could be a low load issue. Could have a lot to do with the airflow too. That's causing some pressure issues. First and foremost, this unit, before I make any major changes, needs to be properly PM'd and cleaned up, okay? Condenser is flattened out. I guarantee that's a split row condenser. I guarantee the inside condenser coil is dirty. We also need to inspect the heat exchanger too, but we know the indoor blower motor needs to be pulled and cleaned. Economizer's not working properly. So at this point, I'm gonna do some more visual checks. I'm gonna visually check out that heat exchanger, and then we're going to give the customer a list of problems. But I got the unit operational, okay? The economizer was not letting it turn on. Now, I did not check voltage on the economizer simply because of all the corroded terminals. So it's very possible that it would have been in a call for cooling, free cooling basically, that it was cool enough outside when I first got here, but the dampers weren't open, okay? And I found a bunch of corroded terminals in there, and just personal experience, I know I'm not even gonna dive down that rabbit hole of trying to diagnose that thing. All right, I do not see any cracks in the heat exchanger at this time. It definitely doesn't look good though. Lots of corrosion, but no cracks, no visible holes or anything. But I'm still not gonna fire the heat up. I'm just gonna tell them that we've got no heat and we need to diagnose it further. Also, again, going with the fact the unit needs a good PM, look at the inside of this. It's full of cobwebs all inside there. So there's no way we're firing the heat. So heat is permanently disconnected. Gas valve shut off. Gas valve shut off over there. So that way, you know, they can have us diagnose it. But we're coming into the spring. They're not gonna need heat. This is their kitchen. Yeah, so we are going to give them an estimate. And also too, these contactors are going to be part of that estimate, because I saw them sparking when they're making bad contact, you know, when we were turning it on and stuff. So they just need a whole lot of stuff on this unit. Again, using my senses and not just walking away. As this unit's been running for about 15 minutes, one of the condensed fan motors is going bad too. I can hear the bearings in it going out. So we're going to add that to the list too. So again, big picture diagnosis, guys. Don't put on the blinders and just walk away. There's so much opportunity out here. Legit opportunity. I'm not selling the customer any snake oils. I'm just making good, honest money by stating them with the facts, what's wrong, and then letting them make the decision. Hey, they may want to change this unit. So be it. You know, I'm just going to give them the facts, give them an estimate, and let them make that decision. And last but not least, I went ahead and tested cooling from the thermostat to make sure that we're getting a call for Y1 and Y2. So we pulled in for Y1 and we're waiting for Y2 to call, and then we'll be completely done with this and be able to give our proper estimate. Okay, right off the bat, I want to cover a few things that I know people are going to mention. Number one, the gas line is hideous, okay? We see gas lines like that so much that sometimes I don't even really like bring it up, okay? Definitely, if I did any work on the heating side of that system, I would repair that gas line, okay? Especially if we come in and do a diagnosis on the heater, I would go ahead and repair the gas line. We do have to use, or we don't, we still, I shouldn't say we have to, but we do use flex gas line here in California as an earthquake thing. But there's definitely a better way to do that gas line for sure. Okay. The next thing is, I realized as I was watching the footage that I made some assumptions, and it's very important when you guys are working on this stuff that you verify voltage. Okay. I have a bad habit of not verifying voltage when I shut off disconnect switches. Now, I do have ways of testing it. Sometimes I check other ways and I may not get it on camera, but I know for a fact that I did not verify that the disconnect switch was disengaging all three poles. Now, granted, I wasn't sticking my hands in the high voltage side, and if I was going to start getting into the high voltage, I usually do instinctually pull out my meter and verify that power's off, but I just realized as I was reviewing the footage that I never grabbed my meter out and verified, you know, that the disconnect was actually shutting the unit off. Understand something, that I bring everything up to the customer and I let the customer make the decisions, okay? In this particular situation, this particular customer, they supply their own equipment. So what I do is I go to them with a list of problems and I tell them, hey, I really don't think this unit's worth repairing, but here's a quote to repair it. Now, if they choose to repair it, I actually make money off of it. If they choose not to repair it, I don't really make anything. So it does give credit, or it does validate my suggestions sometimes when I tell them, hey, I really think you should consider replacing this unit, okay? There's a lot of things that go on behind the scenes in my videos that you got to remember. I'm not going out there with an intention of making these videos. I just turn the camera on and record my thoughts sometimes. So there is a lot more that goes on behind the scenes when I'm doing this stuff, okay? But this is just a typical call for me, just going there, looking at everything, giving them all the facts and letting them make that decision. Okay, this unit is in really bad shape. The customer knows it. I have some footage of the other AC that I repaired on this one too. And again, I brought up in the beginning of this video that I'm looking for service technicians. Send me an email, hvacrvideos@gmail.com, and we can talk. I'd love to talk to you about potentially hiring you and bringing you on the team, okay? Really appreciate you guys taking the time to watch this, especially if you watched it till the end. Do me a favor. If you guys watched it till the end, just let me know. Let me know down in the comments that you actually did. I'm just kind of curious how many people actually watch until the very end and actually watch the end notes on this. So again, see you guys Monday night, 5 p.m. Pacific time, work permitting. I'll be doing my live streams. And that's it. We'll catch you guys on the next one, okay?